All right. So I am going to start off where I left off. So we were on number, sorry, I'm looking for my pen. I lost my stylus pen. Okay. So we were on number 4. I divided everything by 6m squared in p. So that's what I'm going to do. I'm going to divide everything by 6m squared in p. If you didn't watch the first video, you're just kind of jumping in the middle, and you shouldn't be. So 6m squared in p. So when I divide everything, remember I'm taking out my 6m squared n times p. 24 divided by 6 is 4. M squared cancel out. N divided by n cancels out. P squared divided by p is p. Plus 36 divided by 6 is 6. M squared divided by m squared cancels out. N squared divided by n is n. P divided by p cancels out. Negative 54 minus 9. I don't want him in here. I'm trying to make a video. You're awesome. Negative 54 minus 9. M squared divided by m squared cancels out. I'm left with n squared, p squared. You're totally good, Mr. Walker. Sure. Yes, absolutely. All right, so factor by grouping. We're going to recognize these problems because they have 4 terms. They have 4 terms. So we're going to split the problem into 2 pairs. You're going to take out you're good, bud. I was interrupted from a meeting. We're going to take the problem and we're going to divide it into 2 groups. And we're going to look for the greatest common factor out of each pair. So the parentheses are going to match up. So we're going to look at this first example. We're going to take these 4 terms and we're going to break them up into 2 groups. This is called the grouping method, right? We've done this before. So I'm going to look in each grouping, each parenthesis, and I'm going to ask myself, what is the greatest common factor in this group or in this parenthesis? And I see that I can divide them both by x squared. So I'm going to take an x squared out of my first grouping. Well, when I divide that first grouping by x squared, let's see, x cubed divided by x squared is x, and x squared divided by x squared is a positive 1. So now when I look at my second grouping, my second set of parentheses, I want to find that greatest common factor in that grouping. So I see that both of these are divisible by 2. So when I take out that positive 2, what I'm looking for is a repeated factor. Let's see, 2x divided by 2 is x. 2 divided by 2 is a positive 1. And I'm looking for, we call this the copycat, right? I say we're looking for a copycat. So I have a repeated factor, x plus 1. That comes out first, x plus 1. And then what I have left, x squared plus 2. All right, let's look at example number 6. So again, I'm going to factor this by grouping. So when I look at my first group, I have a 4 and a 10. Both of those are even, so I can divide by a 2. And then I remember that I have the variable terms, and I'm looking for the smallest power. I have a cubed and a squared, so I can take an a squared out of both of these. So when I take out my 2a squared from my first grouping, let's see, 4 divided by 2 is 2. A cubed divided by a squared is a. 10 divided by 2 is 5. And a squared divided by a squared cancels out. So the second grouping, let's look at our second grouping. I have a negative 6 and a negative 15. So both terms are negative. That means I want to take out a negative factor. And 6 and 15 are both divisible by 3. So I'm taking out a negative 3. Negative 6a divided by negative 3a gives me a positive 2a. Negative 15 divided by negative 3 gives me a positive 5. Again, when we factor by grouping, we have to have a copycat. You have to have a copycat, a repeated factor. That means that you essentially pulled a 2a plus 5 out of everything. You factored a 2a plus 5 out of everything. And what you have left is the parenthesis 2a squared minus 3. Okay. Let's do another example. So example number 7. Remember, when we factor by grouping, the first thing I want you to do is group 2 terms at a time. And so we're going to ask ourselves, looking at 2x cubed and x squared, I can take an x squared out of that first grouping. In that second grouping, I can't take anything out except a 1. And sometimes that happens. You can't take anything out except a 1. So when I look at my first group, I pull out my x squared. 2x cubed divided by x squared is 2x. And x squared divided by x squared is 1. In my second grouping, I'm taking out a 1, and it's a positive 1. And that just leaves me with exactly what I had, 2x plus 1. Because remember, we're looking for a copycat. You have to have a copycat to factor by grouping. So the copycat, the repeated factor, 2x plus 1. And then you have to have 2 terms that are left over to make your second binomial, x squared plus 1. X squared plus 1. When I look at example 8, let's see. I'm going to put my 2 groupings together. So example 8, I can take a 5x cubed out. I'm going to start by taking a 5x cubed out of my first grouping. So 5x to the 4th divided by 5x cubed. My 5's cancel out. X to the 4th divided by x cubed is x. Then I have a negative 5x divided by a positive 5 is a negative 1. The x cubes cancel out. When I look at my second term, my leading coefficient is negative. And typically, when your leading coefficient is negative, you need to take out a negative something. Well, the only thing that these 2 terms, negative x and a positive 1, share is a negative 1. So I'm taking out a negative 1. Negative x divided by negative 1 is positive x. Positive 1 divided by negative 1 is negative 1. So again, I have my repeated term, my copycat, if you will, x minus 1 times what's left over, 5x cubed minus 1. So I want to just kind of make sure we understand what's going on. Every time we factor by grouping, we have 4 terms. We break it up into 2 groupings, 2 terms and 2 terms. We find the GCF from each term. And when we factor out our GCF, what we have left over must match what we take out of, like what we have left over in the second term. These have to be copies of each other. Okay? So when you do that, you take your copy, and that becomes your first binomial. Your repeated factor becomes your first binomial multiplied by the GCF from the first problem added to the GCF from the second problem, right? Or from the second grouping. Okay, so that's what that looks like. I'm going to stop right here. We'll do the zero product property tomorrow. I'll finish up with the zero product property tomorrow. But what I do want to do is potentially make up 2 more problems. So I'm going to do, I'm going to do 4x squared plus x. Actually, I'm not. I just can't think of any more problems right now. So here's what you have. I just want to